Okay, good morning grade 11s. So this video is a follow-on from general solutions. We've done type 1 and type 2. So those two are a little bit similar, but remember you had to watch out for whether the angle was the same or different between sine and cos. Okay, so type 3 and type 4 are both about factorizing. So with type 3, what you're looking out for is a trinomial, which you guys know is pretty easy to spot. So if you look at this one over here, you have a tan squared and you have a tan and a number. Okay, so that square and then the normal one is your indication that this is going to be a trinomial. Okay, so as you normally would with any trinomial, you're going to get everything to the left and make sure that it's equal to 0. Okay, so you'll have something that looks like this. So if you take your 2 over, it will become minus 2, and then you make sure it equals 0. Okay, so with this stuff, I would recommend you use the K method because you might get a little bit confused with the tan squared and the tan. So what I'm going to do is I'm going to say let tan x equal K. Remember, this was the stuff about putting on your makeup and then taking off your makeup at the end. So we're going to put some makeup on. We're going to make it 3, and then instead of tan squared, we're going to write K squared. And instead of tan, we're going to write K minus 2 equals 0. Okay, so now that looks like a far more familiar type trinomial than this tan squared thingy. So remember, you just create your 2 brackets. If you look at the sign over here, we know that this will be plus and minus. And this is one of those haha trinomials, so you have to look at both 2 and the 3. So the combinations of the factors, this 3 can only be 1 and 3, and 2 can only be 1 and 2. So if I multiply this, I get 3, and then I get 2. Does 3 and 2 minus or plus to make 1? It does. So you know this is going to be your combination, and this is going to be your combination. If it hadn't worked, you would just flip the 1 and the 2 around to check if when you multiplied that, it would give you the 1. Now, I've taught you guys before, if you get confused about where to put the combination, just stick them anywhere, multiply out. If it's incorrect, swap the signs. So I'm going to do it in a different color. Okay, so I'm going to put 1k here, so just k plus 1, and the other one will be 3k minus 2. So if I multiply this out, I get 3k squared, then I get minus 2k and plus 3k minus 2. Okay, so this over here does give me plus k, which is what I want. So this answer is correct. So this answer is k plus 1 times 3k minus 2 equals 0. So if this had been incorrect, all you would have to do is swap your plus and your minus. Okay, so now let's solve. So remember, either k plus 1 equals 0 or 3k minus 2 equals 0. So over here, k equals negative 1, or over here, k equals 2 over 3. Okay, so now that we've solved for k, you can go back to the step where we replace, we take the makeup off. So now you're going to go back to putting tan x where the k is. So tan x equals negative 1, or tan x equals 2 over 3. Okay, so now I can go and I can create 2 general solutions, 2 rounds of general solutions for each of these, because I'm going to get a reference angle here, as well as the fact that I'm going to get a reference angle there, and then you'll see what happens. Okay, so over here, I might have to get another piece of paper. Hold on. Okay, I'm going to kind of continue like this because I don't want to run out of space. So let's do this here. So the first thing we're going to do is we're going to find our reference angle. So x is tan of 1. So if you do this, I mean you guys should know, but let me show you anyways. Shift tan of 1, it's just going to give me 45. So remember, you need to then go and you need to figure out which quadrant is tan negative. So I'm just going to draw it here. Tan is negative in 2 and 4. Okay, so this is 180 minus x, and this is 360 minus x. So over here for our second quadrant, we're going to have x equals 180 minus your reference angle, which is 45, plus minus k what? K 180. So x is equal to 180 minus 45, which is 135, plus minus k 180. Okay, so then if you go to your fourth quadrant, we have the same thing. X equals 360 minus 45 plus minus k 180. So x equals 315 plus minus k 180. Okay, let's check something. Yeah, okay, so essentially what I wanted to show you with these two solutions is that you're going to see that they're the same. If I take 135 and I plus 180, I get 315. So in terms of specific solutions, if you plugged in a 1 there, you would get the 315. If you plugged a 0 there, you would get 315. So both of these are actually the same. Okay, let's go and do 2 over 3. Okay, so let's just separate. Okay, so remember, I'm first going to find my reference angle. So x is tan negative 1, 2 over 3. So shift tan of 2 over 3 is going to give us 33,69. Okay, so that's your reference angle. Then we must go and check which quadrant are we in. This is positive, so we are looking at 1 and 3. 3 is 180 plus x. Okay, so I've been using the same color for way too long, but now it's going to bug my OCD if I go and put in a random color over here. So I'm going to stick with brown. Okay, so yeah, we're going to start with quadrant 1. Quadrant 1 is always easy. So you start with x equals 33,69 plus minus k 180. So that's done. Then the next one we have to do is quadrant 3. Quadrant 3, x is going to be 180 plus 33,69 plus minus k 180. Okay, so let's sort that out. 180 plus 33,69 is going to give me 213,69 plus minus k 180. Okay, so I want you to take note again. What happens if I say 33 over here and I plug in a 1 there? So 69 plus 1 times 180. So I'm finding a specific solution. Do you notice I get 213,69? So you will notice that it doesn't work with sine and cos, but with tan, both general solutions are exactly the same. They give you the same answers. Okay, so you would have to do 2 different ones for these, for the 2 numbers, because remember this is a trinomial, so you always get 2 roots or 2 answers for trinomials. But with regards to the 2 quadrants that you find, and then you go and find 2 specific general solutions, they will give you the same answer. Okay, cool. That only works for tan. Alright, but the important thing with this one is, did you understand the trinomial situation? The first step was to look out for one of the ratios squared and then 1 by itself. That should give you an indication that it's a trinomial, obviously, as well as a separate number. If this wasn't there, you could just use a common factor. You could take out tan x as a common factor, but you'll see that will be type 4. Okay, cool. So just remember, look out for trinomial. Once you realize that it's a trinomial, to make your life simple, use the k method. once you've solved your trinomial and you've solved for k, just plug your tan x back in, and then you follow the same steps as before. With the trinomial, you will get two different reference angles. Okay. Alright, what is next? Example 2. Now, this falls under type 3. What I want you to see here is that you have a cos squared and you have a sine x. Okay, so this again is going to give you the idea that it's a trinomial, but it might be confusing that this is cos and that's sine, because then how can it be a trinomial? But you need to remember that you have learned an identity. You've learned that cos squared x plus sine squared x is equal to 1. And then if you manipulate this a little bit, you know that sine squared x is the same as 1 minus cos squared x. Alright, and cos squared x is the exact same as 1 minus sine squared x. These are quite important for this kind of example in type 3. So if you think about it, you are wanting, you can replace this one. You can't replace that one because you don't have an identity for a sine x on its own. But you could replace the cos squared x with 1 minus sine squared x. We have a little identity for that. And then you will have sine squared x and sine. So that could work out quite nicely. So let's go and replace the cos squared x with 1 minus sine squared x. So put it in a bracket just so you multiply out nicely. Sine squared x minus 5 sine x equals 1. So now let's multiply out. So we get 3 minus 3 sine squared x minus 5 sine x. And while I'm at it, I'm just going to bring the 1 over, equals 0. Alright, now rearrange it nicely. So in the front, I'll leave the minus 3 sine squared x minus 5, minus 5 sine x, and then 3 minus 1 is going to be plus 2. Clearly losing concentrate. Actually, that's going to bug me. Let's sort this out. Let's just use typics. Okay, so minus 5 sine x. Okay, so now you've got a trinomial now. Can you see it? Sine squared minus sine x plus 2. Okay, so what I would do is I would immediately go and use your k method. So now we're going to say let sine x equal k. So now wherever I see a sine, I'm going to replace it with k. So now you'll have minus 3k squared, because it's sine squared, minus 5k plus 2 equals 0. Okay, and then this is a normal trinomial. We don't like that minus in front, so let's multiply everything by a negative sign. So it becomes plus 5k minus 2 equals 0. And I think this is like the exact same trinomial we had before. Is it not? No, it's got a 5 in the middle. Okay, but anyways, it's one of those chacha ones again. So we're looking at the 3 and the 2. So our combination is 1 and 3 and 1 and 2. If I multiply that, and let's sort out the signs as well so we know. This is a negative, so it's going to be plus and minus. If I multiply this, I get 3. If I multiply that, I get 2. So that doesn't work because 3 minus 2 is 1 and we want 5. So let's flip the 1 and the 2. We get 1 and 3 and 2 and 1. If I multiply this, I get 6 and 1. Now that works because 6 minus 1 will give me 5. So this is my combination and that's my combination. Like I said before, if you're unsure which bracket to stick it in either one, and then you can just multiply afterwards and make sure. So I'm going to put k plus 2 in the first one and 3k minus 1 in the second one. And now let's multiply out. So here we get 3k squared. Then we have minus k plus 6k and then minus 2. So again, we chose really nicely because minus k plus 6k is positive 5k, and that's what we were looking for there. So that is correct. So now we can write k plus 2 times 3k minus 1 equals 0. So let's solve. So therefore k equals negative 2, or let's just say 3k equals 1, therefore k equals 1 over 3. Okay, so remember I said to you this is a trinomial, right? So you will have two answers, two different reference angles. I'm just going to get another page. We're running out of space again. Okay, so with this over here, let's go and work out our two different reference angles. Let's get another color too. So the first one, reference angle, is going to be, let's replace it back, sorry, before we do that, let's replace it back. So instead of writing k, I'm now going to rewrite sine x. Sine x equals negative 2, or over here, sine x equals 1 over 3. So therefore x equals shift sine, so sine negative 1 of 2. Remember, you always take the positive one. So shift sine of 2, it does not exist. So therefore, for this one, there is no solution. Okay, that could happen from time to time. There's not an issue with having no solution. Okay, over here, this one will then clearly work because it's nice and small. So sine x equals sine of negative 1 of 1 over 3. So x equals, so we say shift sine 1 over 3 is going to be 19 comma 4, 7. Okay, so therefore we need to now figure out what's our quadrant. So CAST, we're looking for where sine is positive. Sine is positive in 1 and 2. Okay, so for quadrant 1, we know that it's just going to be the angle itself. The angle itself is 19. So 19, 47 plus minus k of, not 180, but 360. Remember, this is sine. Cool. And then we must do it for quadrant 2. Remember, quadrant 2 is 180 minus. So this is 180 minus 19, 47 plus minus k, 360. So x is 180 minus 19, 47, which is 160, 51 plus minus k, 360. Okay, so these will be my two general solutions for sine, and as we saw over here, this one was not a solution. It didn't work out nicely, so there was only one answer. Alright. Okay, so that is type 3. Just to remind you, you are looking out for something squared and something normal. If you can see that it's a combination of cos and sine, where the one is squared and the other one is normal, just try to use your identity and see if that works. If it's like a combination of tan and sine, that wouldn't work because you can't replace this. Okay. Alright. So I hope that makes sense. So replace it, use your K method, get two solutions, and then solve for your general solution. Okay. Last but not least, type 4. This one is actually far simpler than type 3. I did it in a bit of a funny order. But with this one, it's also factorizing, but as you can see, there's just a common factor. So there's a cos and a cos over there. So all you need to do is take it out as a common factor. So you're going to get cos x, open bracket. Over here, this is clearly 1 left, minus, and then over here, you're left with 4 sine x equals 0. So that's simple. So we could say, therefore, cos x equals 0, or 1 minus 4 sine x equals 0. Okay, so now we're going to solve for them individually. Let's just sort this one out nicely. So negative 4 sine x equals negative 1. Therefore, sine x equals negative 1 over negative 4, which is just positive 1 over 4. Okay, so let's do cos x. So our reference angle here is going to be shift cos of 0. So x equals, shift cos naught, which you know is just 90. So 90 is just going to be x equals 90 plus minus k, 360. You'll find the other one, it'll give you the same thing. Let's just do it anyway. So this is positive. So yeah, it doesn't, you just leave it like this. Sorry, I'm losing my words today. Let's go on to sine of 1 over 4. So if I shift sine of 1 over 4, it's going to be 14. So x equals 14, comma 48. So over here, sine is positive. Quadrant 1 and quadrant 2. So x equals for quadrant 1, 14, comma 48, plus minus k, 360. That's done for quadrant 1. Quadrant 2 is going to be x equals 180 minus 14, comma 48, plus minus k, 360. So therefore x equals 180 minus 14, comma 48, which is 165, comma 52, plus minus k, 360, and that is done. So as you can see, type 4 is pretty easy. You're just looking for a common factor, you take it out, you let, like you can see here, either cos x equals 0 or 1 minus sin x equals 0. Yeah, alright, I think that makes sense. I hope that you guys understand. As per usual, send me a message if you need any further assistance.